morning. Next topic is power series. I think this is last unit, fifth unit. Starting topic is power series. Its definition is an infinite series of the form. An infinite series of the form summation n equal to 0 to infinity. Summation n equal to 0 to infinity an into z minus z naught whole to the power of n. An into z minus z naught whole to the power of n. That means if I expand this first term, if I put n equal to 0 in this, you will get a naught. N equal to 1, the expression is a1 into z minus z naught. N equal to 2, z minus z naught whole square, and so on, like this. Okay, if I want to write the nth term, this is the nth term whole to the power of n and up to infinity. Up to infinity. Take this as equation 1. Is called, this infinite series is called power series about the point. Power series about the point. What is the point here? About the point, this is the z naught. About the point, z equal to z naught. About the point, z equal to z naught. And what are these constants here? Here, these constants a naught, a1, and so on are real or complex. Or real or complex constants. Real or complex constants. Okay, so power series expression is what in terms of complex. You know, infinite series in your first semester, that is a real series. Where what is that real series in our topic first semester? That is simply summation an, right? Some series, sin x expansion, cos x expansion, like that. Okay, summation an into something geometric series is there, right? Next one, p series test is there, right? Some series expansion in terms of real variables. Now this is in terms of complex variable z. What is that? A naught, first write the constant, plus a1 into this z minus z whole power 1, a2 into z minus z power whole power 2, and so on. Such series is called power series about the point z equal to z naught. About the point z equal to z naught. And for this series, convergence, same like in real series, we discussed about convergence, divergence, like that. Here also, we have to discuss convergence of the power series. Convergence of the power series. Here, Z0 is called center of the power series. Z0, this point, Z0 is called center of the power series. Center of the power series. Okay. So, simply if Z0 equal to 0, if Z0 equal to 0, if Z0 equal to 0, then power series about z equal to 0 is, what is that power series about z equal to 0? Summation n equal to 0 to infinity an into z minus z naught. That is z naught is 0. So simple a2 z square and so on. This is power series about, if I want to write nth term, this is called nth term, an z power n. An z power n. Done. Now, see the convergence of this one, convergence of this power series. Consider the set of all points in the complex plane. The set of all points. Set of all points in the complex plane. Set of all points in complex plane at which the power series is convergent. At which the power series is convergent. That means I'm considering one complex plane, and in the complex plane at all the points the power series is convergent. And let capital R be the radius, capital R be the radius of the circle, radius of the circle with center at Z0, with center at Z0, that contains all the points, that contains all the points at which the series is convergent, at which the series is convergent. Okay, we are considering Z0 as a center and capital R as the radius of the circle with center at Z0, and this circle contains all the points where the power series is convergent. Then the series is convergent. The series is convergent. Then the series is convergent for all Z. The series is convergent for all Z, for which modulus of Z minus Z0 is less than R. You know, Z minus Z0 equal to R means what? It is a circle. Now mod Z minus Z0 less than R means what? It is also circle at center at Z0 with radius less than R. Okay, the series is convergent. See, series is convergent in this region and divergent for all Z, and divergent for all Z for which divergent for all Z for which mod Z minus Z0 greater than R, greater than R. This real number, capital R is called radius of convergence, is called radius, this is important, radius of convergence. And the circle mod Z minus Z0 equal to R is called circle of convergence, circle of convergence of the power series, Now let me explain the concept. You know, definition of power series, I think it is clear. Now the thing is, for example, there is one complex plane is there. Complex plane means what? Z equal to x plus iy, z equal to x plus iy. Okay, and let me write. Okay, let me briefly explain. This is one complex plane. There are so many points are here, and let me consider one point Z0 here. With Z0 as center, you consider one circle, you construct one circle. With Z0 as center, you construct one circle with radius R, capital R, with radius capital R. Then see, these are the points which lies inside. These are the points which lies inside the circle. If at all these points the power series is convergent, what is the equation of the circle here? What is the equation of the circle? Mod Z minus Z0 equal to R is the circle, equation of the circle. And at all the points which lies inside and inside the circle with center at Z0 and radius R, the power series is convergent. Then this R is called radius of convergence. This is the radius of convergence. And this circle Z minus Z0 equal to R is called circle of convergence. Circle of convergence. Then how to calculate this R? How to calculate this R? Okay. And one more point. If, for example, if R value is 0, R value is 0 means what? There is no radius. Only one point is there. That is Z0. Only one point is there. That is Z0. Then the series is convergent only. The series is convergent at Z equal to Z0 only. At Z equal to Z0 only. If R is infinity, infinity means infinite radius. Okay, at all those points, the series is convergent. That means what? Then the series is convergent at all points. Then series is convergent for all points, means for all Z values. For all Z values. Now, how to find a radius of convergence? Radius of convergence R. Okay, that is the question. And there is one theorem was developed, but statement is enough. Statement is enough. The theorem is, statement theorem is, let summation n equal to 0 to infinity an into z minus z0 whole power n be a power series. Be a power series and L equal to limit n tends to infinity an plus 1 by an modulus, our ratio test. This is nothing but our ratio test. In first semester we did ratio test, D'Alembert's ratio test. What is that? Limit n tends to infinity an by an plus 1 we have taken. Now here an plus 1 by an plus 1 by an. Okay, and the limit value is what? L. Limit value is L. Then the radius of convergence of the power series is, then the radius of convergence of power series is, that is R equal to 1 by L. R equal to 1 by L. If we calculate an by an plus 1, that's okay. Directly R equal to L. Now we have taken limit n tends to infinity an plus 1 by an. So radius of convergence is 1 by R equal to 1 by L. Another one. Using what is we can find limit value using Cauchy's nth root test also. Okay. Using Cauchy's nth root test. We have this L value is nothing but what? Limit n tends to infinity. What is Cauchy's nth root test? An to the power of 1 by n. An to the power of 1 by n. Right? This is mod an. Mod an to the power of 1 by n. You take like this. Mod an to the power of 1 by n. Then R value is same. R value is 1 over L. You can calculate either Cauchy nth root test or using D'Alembert's ratio test. D'Alembert's ratio test. Now, the next point is one point I will tell. Yeah. Afterwards, let us see. Solve this. Find this one. Find the radius of convergence. Just one short question will come in this one. Find the radius of convergence and circle of convergence of the following power series. Of the following power series. First question. Summation n factorial whole square by 2n factorial z to the power of n. 2n factorial z to the power of n. Now, solution. See, what is here? This n means this is n equal to 0 to infinity. Always. Okay, remember. Summation n equal to 0 to infinity an into, you compare the given series with the power series expression, that is equal to n equal to 0 to infinity n factorial whole square by 2n factorial z to the power of n. Therefore, what is z naught value? This is only z power n. So z naught value is what? 0. Z naught value is 0. And what is an value? The coefficient n factorial whole square by 2n factorial. N factorial whole square by 2n factorial. So what is the formula for radius of convergence? R equal to 1 by L. Here, what is the L value? Limit n tends to infinity mod an plus 1 by an. Mod an plus 1 by an. Since factorials are there, we have to apply ratio test only. So let me try. This is n tends to infinity. An plus 1 means what? An plus 1 means n plus 1 factorial. This n plus 1 factorial whole square by, I think I will get 2n plus 2 factorial. By an. By an means what this becomes? 2n factorial into numerator and n factorial is close to denominator. Right? Okay. So let's simplify this. Since all are positive values only, so I can neglect modulus value. So I can write this is n factorial whole square. N plus 1 factorial can be written as n factorial into n plus 1. And the whole square is there. By 2n plus 2 factorial can be written as 2n factorial into 2n plus 1 into 2n plus 2. Isn't it? Multiplied by what? 2n factorial by n factorial whole square. So this terms gets cancelled. For the remaining part, I have to apply limit value. Limit n tends to infinity. This is n plus 1 whole square. Let me take n common. So 1 plus 1 by n whole square. And also 1 by n. And 2 plus 2 by n. Done. So this is L equal to, after applying limit value, what I'm getting? 1 by 2 plus something by infinity, 1 by n, value 0 as n tends to infinity. So this implies L equal to how much? 1 by 4. L equal to 1 by 4. Therefore, radius of convergence. Radius of convergence, I will write CONV. Radius of convergence is R equal to 1 by L. That is R equal to 4. R equal to 4. And what is the circle of convergence? And circle of convergence is what? I told you already. Circle of convergence is what? Mod z minus z naught equal to R. Equal to R. Z naught is what? 0. So mod z equal to 4. Mod z equal to 4. Okay, this is one problem. Any doubts? Calculating radius of convergence. Next, second question. Second question. Summation n factorial by 2 power n z plus 1 minus I whole to the power of n. Right? Now, let me compare this with our power series. We have summation an z minus z naught whole to the power of n equal to what? Given series is n factorial by 2 power n. I will write this power series z minus z naught. Now I will take minus common. So minus 1 plus I will be there whole to the power of n. Is it correct? Plus 1 minus I. Right? Therefore, what is z naught value? Minus 1 plus I. This is z naught value. And what is an value? Just n factorial by 2 power n. N factorial by 2 power n. Therefore, what is the limit L value? Limit mod an plus 1 by an. So limit n tends to infinity mod an plus 1 means n plus 1 factorial by 2 power n plus 1 into, this is 2 power n by n factorial. Okay. So what the next step? This is after simplification. This is n plus 1 will be there in the numerator, n factorial gets cancelled, and by 2 will be there. Is it correct? Is it correct? Right. So even if I take n common, because n tends to infinity is there, I have to take n common limit value. So this goes to what? Infinity. This goes to what? Infinity. Therefore, L equal to infinity. Therefore, radius of convergence is what? Radius of convergence is R equal to 1 by L. So 1 by infinity, that is what? 0. Something by infinity, 0. So R value 0. And circle of convergence. Circle of convergence is mod Z minus Z naught equal to R. What is Z naught? Minus 1 plus I. This implies mod Z minus 1 plus I equal to 0. So this is what? Z plus 1 minus I equal to 0. Equal to 0. Okay. That means what this is? This is nothing but circle. This circle having, you write like this. This circle of convergence having center at what? Having center at Z equal to minus 1 plus I with radius 0. With radius 0 means what? Radius 0. Therefore, at this point only, therefore, at Z equal to minus 1 plus Y only, the series is convergent, right? Only at one point only, at Z equal to minus 1 plus I only, the series is convergent. Done. Okay. Now, takes 2 problems assignment. Summation 1 plus 2 by n whole square into Z power n. You can apply Cauchy's nth root test for this problem. N to the power of log n into Z to the power of n. N to the power of log n into Z to the power of n. And one more point. Yeah, that's also easy. Let me take another problem. Okay, show that the following power series, is convergent in the given region. Okay, first problem. Summation Z to the power of 2n by 4 to the power of n into the power of alpha, where alpha is positive real number, and the reason is given as mod Z less than 2. Okay, is it clear? Right? Now you can take this one entire in all the problems, Z naught equal to 0. Is it correct? What is Z naught? 0. And whole power 2n is there here in particular. So nth power series Zn denotes the nth term of the power series. You write like this. Now consider you write here Z equal to Z naught is 0. Z minus Z naught is 0. Okay, you write like this. Here Z naught equal to 0. And let Zn denote the nth term. Denote the nth term of the power series. Nth term of the power series. What is not an? What I am taking? Zn. Zn as the nth term of the power series. Nothing but, so here we have taken an nth term as what? Zn. Therefore, limit an plus, okay, afterwards I will apply limit. Let me calculate first its value. Mod an plus 1 by an, nothing but what? Zn plus 1 by Zn. Zn plus 1 by Zn. That is equal to modulus of, let me write, what is Zn? Z to the power of here, nth term now. Why I am taking in terms of Z means, let's see, Zn equal to, what is the given term? Z to the power of 2n by, Z to the power of 2n by, how much? 4 to the power of n power alpha. 4 to the power of n power alpha. Okay, this is nth term I have taken. And why I'm completely taken this one as nth term. And one more point. See, if there is any ambiguity, I will clear that. See, question is what? Show that the following power series is convergent in the given region. That means I have to show this power series is convergent in this region mod z less than 2. Done? For example, if I take an value as what? 1 by 4 power n power alpha. 1 by 4 power n power alpha. I will not get the region in terms of z directly. So I am considering entire this as nth term. That since that term is there, I denote this nth term as Zn. Okay, that is the reason. To get the region value directly in terms of Z, I am considering Zn as entire function. Now, why it is not moving? Now, Zn plus 1 by Zn, what is this value now? Just wait. It's stuck on this one. The screen was stuck. Yeah, it's working. Yeah. Now, Zn plus 1 means what? Z to the power of n plus 1 means this becomes 2n plus 2 by 4 to the power of n plus 1, n plus 1 whole to the power of alpha. And by Zn means what? This 4 to the power of n to the power of alpha by z to the power of 2n. That is equal to, now there will be z square here and 4 will be here. If I take n power alpha common, this becomes 1 plus 1 by n whole power alpha will be there. Any more corrections? N power alpha common, n power alpha, yeah, exactly this. Any corrections? Correct, right? This is mod. Now, this is the value of Zn plus 1 by Zn, which is in terms of Z. Now let me apply limit. L equal to limit n tends to infinity Zn plus 1 by Zn. That is equal to, what is this value then? Limit n tends to infinity mod limit is for n terms only. Done, right? So this is equal to, I will get z square plus 4 only, L value. Z square plus 4 only. Got it, right? Then what is the convergence? Therefore, radius of convergence is, what I have for convergence, this should be less than 1. For convergence, I have, we have mod z square by 4 less than 1. That implies mod z square is less than 4. Then what is mod z becomes? What is mod z becomes? Less than 2. Mod z becomes less than 2. Actually, I have to consider what R value, no? For convergence, R. Z minus Z naught less than R. This is 4 by Z square you will get. Anyway, 4 by Z square. Both are correct. No problem. Right? You can take like this also. For convergence, we have this mod Z square by 4 value must be less than 1. Is it correct? Any corrections? This is Z square by 4, right? Zn plus 1. So this is the radius of convergence. Let me take another one. Summation. Same question. N factorial by n to the power of p, z to the power of n. P is positive integer. P is positive integer. And what is the region? Z equal to 0. What is the region? Z equal to 0. N to the power of p. Okay. Now, solution. Let what is Zn I have taken. Now nth term. I'm taking completely nth term to get the region value z to the power of n. So Zn plus 1 is nothing but n plus 1 factorial by n plus 1 whole power p z to the power of n plus 1. Then mod Zn plus 1 by Zn value. So this is mod n plus 1 factorial n plus 1 whole power p z to the power of n plus 1 into by Zn means n to the power of p by n factorial into z to the power of n. You will get, right? So that is equal to 1 n factorial will get cancelled. So n plus 1 will be there and z will be there. And n power p, this is 1 plus 1 by n whole power p will be there. Is it correct? N power p taken common, done, right? So this is limit n tends to infinity mod Zn plus 1 by Zn. What is this value? Limit n tends to infinity mod n is common 1 plus 1 by n by 1 plus 1 by n whole power p into z. So since n value is here, this value is infinity. This value is infinity. Therefore, this is L value. Therefore, R equal to 1 by L, that is 1 by infinity 0. 1 by infinity 0. Therefore, R value 0 means what? What is this power series? This power series is Z minus Z naught. Z naught value 0. Okay. R equal to 0. Therefore, the circle of convergence. The circle of convergence is mod Z minus Z naught equal to R. That is mod Z equal to Z naught is 0 and this is also 0. Therefore, the series is convergent. The series is convergent. What is Z naught value? Here, Z naught value 0. You can solve these problems by using previous technique also to find the region. The series is convergence at Z equal to 0 only. At Z equal to 0 only. Next one. Just this is brief introduction about radius of convergence. Now, the main topic is Taylor series. In real variables also there is a Taylor series. Now in complex variables. When you say Taylor's theorem or Taylor series. Taylor's theorem statement. A function a complex function f of z that is analytic. See, what is the question condition? It should be analytic. That is analytic inside a circle. Inside a circle, mod z minus z naught equal to r. See, what is the condition? F of z is analytic inside the circle with center at z naught and radius r. The center at z naught and radius r may be represented inside this circle as a convergence power series. As a convergence power series. How? F of z, this is the function. I have to express this one as a series expansion. Summation an z minus z naught whole to the power of n. N is from 0 to infinity, where an, this is very important, an equal to 1 by n factorial nth derivative at z naught. This is the Taylor series expansion. That is, now let me expand this. That is, f of z equal to what is the first term? A naught plus a1 into z minus z naught plus a2 into z minus z naught whole square and so on, plus an into z minus z naught whole power n and so on. Now what is an value? 1 by n factorial by f, same as it is like in our real variables. What is a naught value then? See, what is a naught? 1 by 0 factorial 1, no derivative. That means f of z naught plus z minus z naught. A1 means what? 1 by 1 factorial first derivative, right? Z minus z naught f dash z naught plus next term is what? Z minus z naught whole square by factorial 2 f double derivative z naught plus z minus z naught whole cube by 3 factorial f triple derivative z naught and so on and so on, triple derivative and so on, plus what is the nth derivative? The z minus z naught whole to the power of n by n factorial f n z naught and so on. You know this power series expansion. This one is called Taylor series. About Taylor series of f of z. Taylor series of f of z about z equal to z naught. How to write? F of z naught plus z minus z naught into first derivative at z naught, z minus z naught whole square by factorial 2 into f double dash z naught, and a third derivative, and next one nth one, and next one nth one. Okay. Now this is the formula. When z naught equal to 0, then what is the series become? See, f of z equal to f0 plus, you know this, z into f dash 0. Previously x terms are there in real variables. That is Maclaurin series, right? Z square by factorial 2 f double dash 0, z cube by factorial 3 f triple dash 0 and so on, z power n by n factorial f nth derivative 0 and so on, is called Maclaurin series. Of f of z about z equal to 0. Maclaurin series about z equal to 0. Okay. And you know, same logic, just write this series expansion, but remember this formula. This is Taylor series expansion, and where an value is that's 1 by n factorial nth derivative at z naught. And now let me solve. if you want to get Taylor series expansion questions, find that's simple. Find Taylor series, Taylor's expansion. Find Taylor series of f of z equal to 1 by z plus 1 whole square about the point z equal to minus I. About the point z equal to minus I. Why I am telling this problem? Because the point is very important. The point is very important. See, this is the Taylor series expansion about the point z equal to z naught. So what you will get, f of z naught is a constant value, f dash z naught is a constant value, f double dash z naught is a constant value. So derivatives are the constants. So what are the variables? Z minus z naught. So you will get Taylor series expansion in terms of what? Z minus z naught expressions. Okay, so point is very important. But what is the function is given here? See, since we have to find Taylor series about the point, Taylor series of f of z about the point z equal to minus I. That is, what is z naught value? Minus I. Z naught value minus I. Okay. Take z, take this one, I this side. Okay, minus I this side. Take z plus I equal to another variable. I'm taking u. Take z plus I equal to u. At last, I will substitute u value. Then, this is very important point, all of you. Z equal to minus I. So I am taking z plus I equal to another variable. See, z equal to minus I means what this becomes? Z minus z naught becomes what? Z plus I. Next, whole square becomes what? Whole square. Whole cube means I'm getting z plus I terms. Z plus I terms in the Taylor series means what? It is the series about the point z naught equal to minus I. This is important. Okay, right? Now z plus I equal to u. Then what is f of z becomes? F of z is what? 1 by z plus 1. There is a change, modification in z. Put z equal to, this implies z equal to how much? U minus I. U minus I. So this is u minus I plus 1 whole square. U minus I plus 1 whole square. Right? Okay. Then how to solve this? You can write this equal to, you try like this. See, 1 by, I will write like this, 1 plus u minus I. Can I write? But no. I will write, I need binomial expansion. For that, what I have to take common? What is a constant? I will write like this, u minus I minus 1. Is it correct? Whole square. Right? Done. So I will take this one, I minus 1 is common. Outside it becomes whole square. So 1 by 1 minus u by, yeah, that's correct. 1 minus u by I minus 1 whole square. Correct, right? So I will take this one to numerator. 1 by I minus 1 whole square. 1 minus u by I minus 1 whole to the power of minus 2. Whole to the power of minus 2. Any corrections? Right? Now, this I will write 1 by I minus 1 whole square. What is this value? 1 by I square plus 1 minus 2i. 1 minus u into, I will rationalize this. This is I square minus 1 whole to the power of minus 2. that is equal to 1 by, this is just minus 2i. 1 minus, this is minus 1, minus 1, minus 2, that is plus. What I am getting, by 2 will be there. Is it correct? I plus 1, I square, sorry. Yeah, right. I plus 1 by I square minus 1, minus 1, minus 1, plus 2. So 1 plus I by 2 into u whole to the power of minus 2. Right? Now, minus 1 by 2i. What is the formula? I think you know this formula. Okay, anyway, I'm writing the formula. 1 plus x whole to the power of n expansion. 1 plus nx, n into n minus 1 by factorial 2x square, n into n minus 1, n minus 2 by factorial 3, x cube, and so on. This is the formula. Let me apply that formula. So this is equal to minus 1 by 2i, big bracket, first 1 plus, what is n value? Minus 2, n into x, what is x value? This 1 plus u by 2 plus n into n minus 1 by 2 factorial, 1 plus I whole square u square by 4 you will get. Done. If you want one more term, n into n minus 1, n minus 2 by factorial 3, 1 plus I whole cube u cube by 8, and so on, right? If I rationalize this, multiply divided by I by 2i square. Now what is this? 1 minus 2 gets cancelled, 1 plus I into u, 2 gets cancelled, plus 3 by 4. Any corrections? Yeah, 3 by 4, 1 plus I square plus 2i. Done. U square. Okay, I will take up to here only. That's enough for me. So what is this? This is equal to I by 2, 1 minus 1 plus I into u, right? Plus these 2 gets cancelled, plus 1, this one gets cancelled, 2 2s are, that is 3 by 2. I will be there. Yeah, I u square, and so on. Take I by 2 inside. Take I by 2 inside. Then this is I by 2 minus 1 by 2 I minus 1 u, I minus 1 u, plus I into I square, that is minus 3 by 4 u square, and so on. Any corrections? Now at last substitute. Now f of z equal to I by 2. This is the constant. Plus 1 minus I by 2. What is u value? Z plus I. Now you substitute 3 by 4, z plus I whole square, and so on, is the Taylor series. Is the Taylor series of f of z about z equal to minus I. About z equal to minus I. Okay, this is one more problem. Now, let me take one problem. Expand. Firstly, expand f of z equal to 1 by z about z equal to 2. About z equal to 2 in Taylor series. In Taylor series, obtain radius of convergence. Obtain radius of convergence. Now, solution. F of z equal to what? 1 by z. And what is the point is given as? Z naught is given as 2. Given. Z0 is given as 2. So already I told you Z equal to Z0 equal to 2. 2 means what? Let Z minus 2 equal to some U. So Z equal to what? U plus 2. U plus 2. Z minus 2. This one. You can neglect this. This is the point is Z equal to so Z minus 2 U. Then what is f of Z becomes 1 by Z, that is equal to 1 by U plus 2. 1 by U plus 2. I can find this one, right? What is this f of, yeah, I can find using binomial. 1 by 2 is common, 1 by 1 plus U by 2, simple, right? This is 1 by 2, take 1 plus U by 2 to the numerator. So 1 by 2, 1 plus x whole power minus 1, 1 minus x plus x square minus this and so on, right? So this is f of Z equal to how much? 1 by 2 minus U by 4 plus U square by 8 minus U cube by 16 and so on. U cube by 16 and so on. Now substitute Z U value 1 by 2. What is U value? Z minus 2. Isn't it right? Plus Z minus 2 whole square by 8, right? Minus Z minus 2 whole cube by 16 and so on is the Taylor series. Is the Taylor series about Z equal to 2. About Z equal to 2. So can I write, we can write, we can write f of Z as 1 by 2 minus Z minus 2. I will write like this because I need nth term. 1 minus 1 by 2 square into Z minus 2. Done. Plus 1 by 2 cube into Z minus 2 whole square minus 1 by 2 power 4 into Z minus 2 whole cube and so on. Done. So what is the nth term? If I want to write nth term, plus minus 1 whole power n. If I put, okay, let me write first. This is first term 2 power 1, second term 2 power 2, third term 2 power 3, right? This is 0. This is a naught now. This is a naught. Remember, this is a naught. This is a1. This is a2. This is a3. So an. This is minus 1. This is okay. When a1 is there, n equal to 1, this should be minus, correct? When n equal to 2, this should be plus, right? And first term 2, second term 3, third term 4. So this is 2 power n plus 1 into Z minus 2 whole power n and so on. And so on. This is nth term. Therefore, what is an? Nth term is what? Minus 1 whole to the power of n by 2 power n plus 1. 2 power n plus 1. So L value mod an plus 1 by an. So what is this? Mod, done, minus 1 whole to the power of n plus 1 by 2 power n plus 2 into 2 power n plus 1 by minus 1 whole power n. So what is this value? This minus 1, anyway positive, 1 by 2 you will get, right? Since modulus is there, 1 by 2 will be get. Therefore, what is R value? 1 by L, that is 2. That is 2. Done. Therefore, what is the question? Obtain radius of convergence is the radius of convergence. And what is the circle of convergence? Circle of convergence is what? Mod Z minus Z naught equal to R. Here, what is Z naught? The point is given as what? 2. So mod Z minus 2 equal to 2. Mod Z minus 2 equal to 2. Circle of convergence. Right? Therefore, Taylor series. Already in the statement it is there. Taylor series is convergent in within the circle. Do you remember the statement? Inside the circle, mod Z minus 2 less than 2. Mod Z minus 2 less than 2. Okay, these are some problems. in Taylor series. I will tell more problems in the next class. Any doubts?